In this video, I'm going to do an overview of the Phoenix Pack internals. I'm going to work my way through, I guess, the electronics section first, and then into the pneumatics and mechanical features. I guess to begin with, we can start with the power source, which is a 3-cell 4500 milliamp hour lithium polymer battery, commonly used in RC cars and things like that. With this battery, it'll run on average about 4.5 hours maybe, depending on how the pack's used. That goes into a battery auto cutoff circuit, which is right here, if you can see it, which is to protect the LiPo battery from being over discharged, which can damage it. From there, that goes into the power supply section, which consists of a few DC to DC converters or switching power supplies. We have this one right here is a 10 amp 5 volt supply, and then I have two 12 volt I think these are 4 amp supplies or 5 amp supplies. One of them's dedicated for audio, digital audio amplifier located on the motherboard. It's a 30 watt stereo amplifier, 15 watts per channel. It drives 2 speakers, but the thing is connected as a mono amplifier. Now, the power then goes from those two switching regulators to the power distribution board, which is right here, and that is provides interconnection to all the auxiliary devices, such as the power cell light display and the end filter lights and things of that nature. The ribbon cable that comes off of it supplies power, a few control signals to the main logic board, which does the sound and controls everything, including the solenoid valves and the cyclotron lights. Now that board then connects to the RGB LED driver board, which you can see right there, and that drives the high wattage, high output RGB LEDs that are on the cyclotron rod modules that you can see, and there's 4 of those. Also, there's a module right here. It's actually 3 inverters which provide the power to the EL wire that's made into the umbilical cord that goes to the thrower, and that it has a small circuit board on the side of it. If I can get it out of here, you can see it, that flashes the lights in a random sequence when it's firing. For the most part, that's the electronics. I have a couple little boards that I made just to flash some lights, like this one right here flashes the lights that are on the gauge display, and there's another board I built for the thrower that flashes a couple lights and kind of acts as an interface to the main control logic board. Now, the pneumatic section consists of these manifold, these fittings here that connect to the cans, the aerosol cans, which are one of them right here, and one of them goes like this, inverted. Okay, and then the other one goes like this. The one that's inverted, of course, is for the venting system to produce the steam effect, and the red hose connects to that one, and the blue hose goes to the other one. I'm not going to connect this right now because I'm not going to be fooling around with that, but I'll explain how it works. Those go to these hoses go into these on-off valves so that the system can be shut off when it's not in use. From there it goes to the control valve, starting with the venting system. We have a small clippered mouse valve that controls the upper vent. Then down below we have an identical clippered mouse valve that controls the lower vent. Let's see where it's piped to two small nozzles that are on either side of the bumper eject mechanism, and they're hidden behind the bumper. The rod eject system, which consists of the main actuator mechanism right here and the 4 rod housings, one which I have loose because I had to do some work on it, like this. Now these all connect by these flexible cables that go back to the actuator. They're all connected together so that when the actuator moves, they all move in tandem. If I push it in like this, you can see how the rod comes out. Please forgive my bad cinema photography. I'm not real good at this, but watch as I push the actuator out, goes back in, and you get the idea. All 4 of these, of course, connect to the, as I said before, the LED driver module. We've got a total of 24 watts worth of RGB LEDs, and it can do 7 different colors. Now this actuator here that moves them in and out is controlled by this clippered 4-way electronic valve, and that is the air supply for that comes off of the front R701 regulator valve, which I actually put to use on this pack for something other than decoration. Of course, that's the valve. If you don't know what I'm talking about, that's the valve that goes in the front. I'm using that to regulate the pressure down to approximately 30 psi. From there, let's see, we have another identical 4-way valve, just like that, when it's mounted to the shell, and it controls the movement of the bumper ejector mechanism. And this is a custom built pneumatic cylinder just for the purpose of ejecting the bumper. And all of this stuff works together pretty well. You've seen it demonstrated. After I'm finished with this video, I'm going to be putting this thing together, and I'll do another video with an overview of all of the functions and how everything works. And I think I've gotten everything. One of the other things I wanted to mention about the electronics, the umbilical cord that connects to the thrower is it features custom machined ends, and part of the reason I did it like this wasn't just because I wanted it to look good, but I wanted it to be easy to remove from the pack, because this pack is kind of hard to handle. It's heavy, and the hose isn't real, it's not real fragile, but it does have to be taken care of. So it's a lot easier to transport the pack with the thrower disconnected. So I made it to where it could be unplugged with these connectors from the pack and stored separately. That's one of the problems with this pack is it's kind of heavy and it's cumbersome, and you have to take it apart to change these cans. And you know, I tried to simplify things as much as I could to make it where the user could take it apart without screwing it up. And for the most part, we haven't had any problems with it. I had a couple minor issues. Wire got yanked out of it, and one of these clippered valves failed when he brought it to Dragon Con, which is really a problem. We tested it all week long, no problems. When he gets there, the valve quits working, so we had to kind of walk him through it on the phone, how to bypass it, and got it working again. And did pretty good. But I don't know if I forgot anything, but I think that wraps it up for now. Like I said, in my next video, I'll explain all the functions in detail. Till then, bye.